Hello, I welcome you all to this another interesting screencast. The problem reads, the catapult is used to launch a ball such that it strikes the wall of the building at the maximum height of its trajectory. If it takes 1.5 seconds to travel from A to B, determine the velocity VA at which it was launched, the angle of release theta, and the height h. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. To start with, let's talk about the basic equations. We have velocity, which is the time derivative of position. We have acceleration, which is the time derivative of velocity. From the two equations, we have one derived equation, A ds equal to V dv. From these three basic kinematic equations, we are able to derive a couple of equations depending on the boundary conditions. But we do have one common equation when acceleration is constant at t equal to 0. We have S naught as well as V naught. So using this boundary condition, we are able to derive the following equation: S equal to S naught plus V naught t plus half ACT squared. V is equal to V naught plus ACT, and V squared is equal to V naught squared plus 2AC S minus S naught. Okay, so let's draw our free body diagram here. We have a component in the vertical direction as well as in the horizontal. And also at this maximum point of the trajectory, we are going to have this component, vertical component, like so. I mean horizontal as well as the vertical component. Let's label them. Of course, we are being asked to determine VA as well as the angle theta as well as H. Therefore, this is VAY, which is equal to VA sine theta. This one is VAX, which is constant throughout, and because it is constant, we expect acceleration for the horizontal motion to be equal to 0. Acceleration to be equal to 0, okay, because VAX, the horizontal velocity, is constant, and this is equal to VA cos theta. At the maximum point of our trajectory, we expect VB at this point, VBY to be equal to 0. While VBX, like we said, is constant throughout, this is going to be equal to VAX. Alright, having said this, we are going to pick this to be our reference. This point here, we'll pick this to be our reference. Okay, this was going to be our reference. So our reference is this is our reference. Okay, this is our reference. Great. Okay, great. So let's start working now. So let's look at what we have. Okay, the vertical component is 0 at B. So this equation becomes good to use. So we use this equation for the vertical motion, and this equation for the horizontal motion. Okay, so we're going to use these two equations. Let's start with the horizontal motion. So horizontal motion, what are we dealing with? These are feet, so we require to convert our acceleration due to gravity to feet per second squared. Alright, so like we said, for horizontal we use this equation S naught plus V naught T plus half ACT squared. Okay, so in our S in our case here is just going to be equal to 18. Our S node is equal to 0. Our V node is equal to VAX, which is just equal to VA cos theta, right? And then our AC, which is acceleration, is equal to 0. Therefore, this just becomes 18 equal to VA cos theta times time. And time is already given, right? We said it takes 1.5 seconds. So we can plug in the time there. So let's write this in terms of this unknown. V cos theta equal to 18 divided by 1.5. What does this give us? Grab your calculator. So 18 divided by 1.5, this gives us a 12. Great. So let's go to the vertical. Let's go to the vertical motion. To the vertical motion, like we said, our acceleration in meters per second squared is this. So multiply this by the conversion factor 1 foot is equal to 0.3048 meters. Meter and meter cancels out. Therefore, this becomes a 32.19 feet per second squared. So therefore, our AC is just going to be equal to minus G, which is equal to 32 minus 32.19 feet per second squared. Of course, even be to use 32.2, that is usually what they use in books. You can go ahead with that. All right. So there we go. What do we have? So here we said because our V component, the vertical component at B is 0, this one becomes useful. Good one to use. So V is equal to V naught plus ACT. And our V is just going to be equal to VBY, which is equal to 0. Right? And then we have T here is equal to 1.5. V naught is equal to VAY, which is equal to VA sine theta. And then we have AC equal to minus 32.19. Therefore, this becomes 0 equal to V naught is just VA sine theta, okay, then minus 32.19 times 1.5. Therefore, VA sine theta is just going to be equal to 32.19 by 1.5. So we have now two equations that we can solve. This one and this one, we are going to divide them. We divide these two equations. So dividing these, then we can write them like so. So we have VA sine theta equal to 32.19 1.5 and divided by VA cos theta divided by 12. So this gives us tan theta is equal to 32.19 divided by 1.5, I mean by times 1.5 divided by 12. And then theta, I create a boundary like so. Then we have theta is equal to tan inverse of 32.19 by 1.5 divided by 12. So this gives us theta is just going to be equal to that's 32.19 times 1.5 divided by 12. Then tan inverse of answer, this gives us a 76.04 degrees. Okay, 04 degrees. Right, so this is the value of theta. This is the value of the angle of release. So let me just work it out again. 32.19 by 1.5 divided by 12, tan inverse of that 76.04. Alright, so found the angle, then we can go ahead and find BA. So let's use this equation to find BA. So we know that BA cos theta is equal to 12, and therefore our VA will be equal to 12 divided by cos theta. So feeding this theta here, okay, then finding our VA therefore will just be equal to cos 76.04, right? Then 12 divided by answer. So this gives us a 49.74 feet per second. So this is 12 divided by cos 76.04, 49.74. So let's find the value of h. So we are going to use again for h, we know the time, we know VA, we also know, so we can use this equation, it can come in handy. We can also use this if you want to, there's no big deal, it's really up to you. So I'll go for this one, okay. So using V squared, V naught plus 2AC S minus this to find h. Okay, so we are dealing with vertical motion. So here our V is equal to our V final is equal to VBY, which is equal to 0, and our V naught is equal to VA, and our VA is 49.74 sine what? Sine 76.04. Okay, so let me just move this. I move it like so, right? This is sine, this angle, okay. And then we have AC, which is just equal to minus 32.9, and then we have our S, which is equal to H, and then S naught, which is equal to our S naught is equal to 3.5, right? So let's work out this. So this stuff will become just a 0 is equal to, where is the equation? V naught squared. So this just becomes a 49.74 sine 76.04 degrees and minus 2 by 32.19, then times S, which is our H, and minus 3.5. So making h subject to the formula, which you can do, I'll make it directly just by using my calculator. So I'll say 49.74 sine 76.04 squared. Okay, and I'll say divided by 2 times 32.19. all right, then I will say plus 3.5. Okay, therefore my h is equal to 39.69 feet. I want to repeat this: 49.74 sine 76.04 and squared, okay, divided by 2 times 32.19, okay, then plus 3.5, 39.69. So found the value of h. I guess we are done. Let's outline the solutions. What do we have? Of course, we have theta that we just found. This is the angle of release, right? This is the angle of release. Then we do have VA. This is the initial velocity, okay, to which the catapult was launched. And then later on we do have H. This is the maximum height that the object or the ball reaches, okay, as it strikes the wall. Okay, I think this is about it, and I hope this video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.